Hey class, so we need to do an intro to some complex fractions and long division. I say intro, but this is going to be a little bit longer than normal. And the first thing I want to say is that in our notes, and we can fix this in class, I used to teach complex fractions one way, and this year I'm going to teach it a new way. So the 3 bullet points that I had there are not exactly the way we're going to be doing this. So if you want to write down the new way, these are the 3 bullet points. We're going to find some LCDs of all of the mini denominators. We are going to multiply the top and bottom of the big fractions by that LCD, and then we're going to simplify and reduce. I actually think this way is going to make it a little bit easier for us. So looking at number 1, this is called a complex fraction because I have a fraction on top of a fraction, all in a fraction, right? Here's one numerator, one denominator, and then I have these mini fractions within those numerators and denominators. Kind of crazy. But here's the thing. What I'm going to do is I'm going to look at all of my, I call these the mini denominators, okay? So technically 1 is over 1, and so is this other one. And I'm going to get the LCD of all of those mini denominators. And the LCD for this is going to be y squared. So I'm just going to write that down. So what I'm going to do next is I'm going to take this bigger numerator and bigger denominator, and I'm going to multiply through by the LCD. And if I do it to the top of the big fraction, I've got to do it to the bottom. So I'm going to distribute the LCD. So 1 over 1 times y squared is just y squared. Technically y squared over 1, but I'm just going to write it as y squared. Now here's what's interesting. When I multiply x over y times y squared, I'll show you up here what's actually happening. Technically that y squared is over 1. It's going to reduce. The bottom y is going to cancel with one of the y's on top, and I'm just left with x times y. Okay? So that's what's happening. I'm going to write it out like this. So I'm distributing the y squared, and I'm left with a minus xy. So by multiplying by that LCD, I should get rid of the fractions on the top. And it should also get rid of the fractions on the bottom. So let's multiply. When I multiply the y squared to the x squared over y squared, the y squareds cancel out. So I'm just left with x squared. Y squared times 1 is y squared, so minus y squared. So I have now found the LCDs, multiplied the top and bottoms by the LCDs. When I do that, all the fractions, the mini fractions, should be canceled out or reduced, and now I can reduce the big fractions. So here on top, I can pull out a y, and I'm left with a y minus x. On the bottom, I can factor to x plus y, x minus y. Now, I do notice exact opposites. So what I mean by that is this is y minus x, positive y, negative x. And here is x minus y. So those are exact opposites, positive x, negative y. And so exact opposites are going to cancel. And that means I am left over, oh wait, silly me. They're not just going to cancel. They will cancel, but what I need to do first is pull out a negative from this one. I'll rewrite it. Silly me, I forgot one step. So now they're going to cancel out. Okay, so now they cancel out, but I have to pull out a negative if I'm going to cancel out exact opposites. So I am left with a negative y over x plus y, and that is the answer. That was kind of crazy. Let's do another one to feel more comfortable. Whew, let's look at number 2. This looks crazy. It's really not that bad. Guys, let's look at these mini denominators. I have an x plus 2 and an x minus 1, and again, I have an x plus 2 and an x minus 1. Okay, so my LCD is exactly that, x plus 2, x minus 1. Okay, so now I'm going to take the big numerator and the big denominator and multiply through by x plus 2, x minus 1. Okay, so be really careful. So when I multiply, I'm going to distribute. In the first fraction, the x plus 2's will cancel. So I am left with the x that was originally there, and then the x minus 1 that did not cancel. I'm going to change this minus to a plus negative 2. And this time the x plus 1's canceled, and I'm just left with the x plus 2. And that's all that's left on the top when I distribute. When I distribute on the bottom, I'm distributing this whole thing. In the first part, the x plus 2's cancel, and I'm left with the 3 and the x minus 1. And in the second part, the x minus 1's cancel, and I'm left with the x on top and the x plus 2. Do not start canceling those. I have to simplify. I have to distribute first and combine, and then I can cancel if possible. So I'm distributing on top. I get x squared minus x minus 2x minus 4. And perfect. On the bottom, I get a 3x minus 3 and an x squared plus 2x. I'm going to keep going. Let's see. I get an x squared minus 3x minus 4 all over x squared, let's see, plus 5x minus 3. Okay, so next we're going to see, does anything factor, does anything cancel? So it looks like my numerator might factor. X minus 4, x plus 1, because that does give me that negative 3 in the middle. But on the bottom, it's not going to factor. Okay, there's no way I can multiply any numbers by 3 that are also going to add to 5. So either the green answer is going to be acceptable because nothing ended up canceling, or I could leave the numerator factored. I don't really care. Okay, so that's the answer there. Okay. Kind of crazy. So that's complex fractions. We'll do another one all together. Let's get into long division. I'm just going to do one example of long division, and we'll do the last 2 examples together. So really quick, remember from 4th grade, long division. So if I divide 229 divided by 4, the first thing I do is I see does 4 go into 2? The answer is no, but does 4 go into 22? Yes, 4 goes into 22 5 times, and then remember I would multiply. 4 times 5 is 20, and then I subtract. So when I subtract, I'm going to say draw the line, change the signs. So I subtract. 22 minus 20 is 2. And then remember we drop down the 9, and then we repeat the process. So 4 goes into 29 how many times? 7 times. Nice. So 4 times 7 is 28. Draw the line, change the sign, in other words, subtract, and I'm left over with 1. So we call this the remainder, okay? So in 4th grade, I think a lot of you guys wrote like 57 remainder 1, but what I want you guys to write is 57, and we take the remainder and we put it over the divisor. We put it over the number we divided by. So actually 57 1/4 is the correct answer. Pretty crazy. That is how we do long division. Guys, we're about to do long division with a polynomial. So there is a lot there's a lot to know for this, okay? And so we're gonna go over the notes together, but I'm just gonna do an example here so that you can kind of see what's going on, but I'll clear it up in class. So the first thing is we take this big part and we're gonna put it under our division sign, okay? And then the bottom part goes outside. So I'll put the x plus 3 out here. Now, one thing you have to really be careful of is you're not allowed to be missing a term. What I mean by that is, see how this jumps from x to the 4th to x squared? It's missing the cubic term. That's not okay. I need to write in the cubic term when I write it in the division symbol. So it's gonna go look like this. We have x to the 4th. Since we do not have a cubic term, I'm gonna write it as 0x cubed. Okay, because 0 times x cubed is still 0. So it's like it's not there, but it kind of is there. And we're going to need it there in order to get this problem right. So if you're missing a term, you put a 0 with it. X squared, then we have our linear term plus x plus 4. And we are going to do this the same way we did it back in 4th grade. We are going to ask ourselves, how many times does x go into x fourth? Or what do I need to multiply x by to get x to the 4th? That's what's going on in your brain. Really, you're dividing. So you're taking x to the 4th divided by x, okay? And that is x cubed, right? Fraction, subtraction. You just subtract your exponents. So that's all we're doing. So the first one is x cubed. Now I'm going to multiply. X times x cubed is x to the 4th. And I'm going to then also multiply. You have to multiply both of the outside pieces by this. So then it's a plus 3x cubed. That is why I had to write in the 0x cubed, because if I didn't do that, my terms would not line up. So now I'm going to draw the line, change all the signs. So I'm subtracting, but I'm subtracting everything. So I have to distribute the negative. Change both signs. If I do everything right, the first part should cancel. 0 minus 3 is negative 3x cubed. Drop down the 3x squared, and let's do it again. Wow. Negative 3x cubed over x. Negative 3x cubed over x. What happens? The bottom x cancels. We reduce the degree by 1. So it's negative 3x squared. Multiply. X times negative 3x squared is negative 3x cubed. Those should always match. 3 times negative 3x squared is negative 9x squared. Oh my goodness. When I dropped this down, guys, I forgot to put the squared. It should have been there. I'm sorry. So now I'm going to draw the line, change both signs. Those should cancel. 12x squared is what I'm left with. Drop down the next term, which is just an x. I did not miss an exponent this time. Keep going. So 12x squared over x is 12x. Multiply. X times 12x is 12x squared. 3 times 12x is 36x. Draw the line, change all the signs. 12x squareds cancel. I'm left with a negative 35x. Drop down the 4. And repeat. Negative 35x over x is just negative 35. Okay, multiply. So we get x times negative 35 is negative 35x. 3 times negative 35 is minus 105. Draw the line. Change both of the signs. 35x's cancel, and I'm left with 109. Now, x cannot go into 109. Okay, so I'm done. This 109 is my remainder. Dang, so my final answer, I'm going to take everything in here is x cubed minus 3x squared plus 12x minus 35 plus 109 over x plus 3. So you take your remainder and you put it over the divisor, and that's the answer. Wow, that was a longer video, guys. Hope you hung in there. We're going to take more notes on this, and we're going to dive a lot deeper into this the next time we meet. Thanks for watching. I'll see you guys soon.